Hey everyone, welcome back to my channel. I am Anusha and welcome to the fundamentals of MLOps. I'm so glad you are here because we were about to explore isn't just theory, it's what powers the machine learning systems behind companies like Google, Microsoft, and Amazon. Let's be honest, building a machine learning model is one thing, but deploying it, maintaining it, and making sure it keeps performing well in real world conditions, that's a completely different challenge. And that's exactly where MLOps comes in. So, what is MLOps? MLOps, short for Machine Learning Operations, bridges the gap between data science and operations. It's the discipline that brings together machine learning, DevOps, and data engineering to automate and streamline the entire ML lifecycle from data collection to production deployment and monitoring. And here is the thing, it's not just a fancy buzzword. Over the past year alone, there's been a 50% surge in demand for MLOps professionals. That tells you how critical this field has become. So let's jump into MLOps lifecycle in action. Now let's walk through the MLOps life cycle, which forms the foundation of everything we will learn in this course. First, we have continuous integration, where your data, code, and models come together. Every challenge is tested automatically, ensuring everything still works as expected. I'll repeat again. So, first, we have continuous integration where your data, code, and models come together. Every change is tested automatically, ensuring everything still works as expected. Then comes continuous deployment, where we push models seamlessly into production using pipelines. Think of it as a conveyor belt that moves your model from lab to real users safely. Next is continuous training. Because data changes over time, MLOps ensures your model can retrain itself automatically when new data comes. Finally, continuous monitoring, where we track model performance, detect model drift, and take corrective action before it impacts users. So these are the four pillars that keep ML systems alive and evolving. Okay. Now, let's jump into the backbone of MLOps. Let's talk about the real hero behind all of this data. Every ML project stands on the quality of its data. So, in this video, you learn how to handle data end to end, from data ingestion and cleaning to transformation and storage in data lakes. We will discuss how large organizations manage petabytes of data efficiently and ensure that models train on reliable, high quality inputs. Next, we will step into the heart of machine learning model development. You will see how to train models effectively, perform hyperparameter tuning, and make the most of CPU and GPU resources. And it doesn't stop there. You will learn how to deploy models into live production environments, handle real time traffic, detect model drift, and use monitoring tools to track performance in action. We will also dive into model serving techniques and explore strategies for smooth model upgrades without downtime. To make this journey practical, you will work on a hands-on project deploying machine learning application for a capstone project. You will set up servers, connect them to online serving environments, and deploy the model end to end. Every step from setup to monitoring is guided with clear demos, and you will build with confidence through action. Now, no ML is complete without understanding the compliance and data privacy. You will learn how regulations like GDPR, HIPAA, and PCI protect user data and what happens when organizations fail to comply. The penalties can be massive. MLOps isn't just about automation, it's about doing things responsibly and securely. We will also explore cloud based MLOps solutions from AWS SageMaker, Azure ML, Google Vertex AI. You will understand how these platforms simplify deployment, scaling, and monitoring, and when to use which project based cloud. MLOps isn't a solo journey. Join the growing MLOps community, share your progress, ask questions, and collaborate. This space is all about learning from each other and growing together. So let's embark on this journey on MLOps with enthusiasm and confidence. By the end of this video, you will just understand MLOps. You will be able to design, build, and manage complete machine learning pipelines from scratch. I'm just pausing here. If you are excited about mastering MLOps and staying ahead in AI revolution, hit that like button, subscribe to Data Enthusiast Era, and let's build the future together. Now we are diving into something every organization is serious about. AI needs to get right how to build an effective machine learning team. We will break it down what each role actually does, from product managers to data scientists, data engineers, and MLOps engineers, and how they'll all come together to move a model from an idea to production. Every ML project starts with one big question: who is responsible for what? An ML engineering team is blend of multiple skill sets, business thinkers, data experts, and infrastructure builders, all aligned together and towards a common goal, creating a model that actually delivers value. Let's start with the people who kick off the process, the project. uh, they are very helpful. To start with, the product management team. The product management team drives the business direction. They identify use cases where machine learning can make a difference. For example, ranking products on an e-commerce site so that customers see the best matches first. Once the use case is clear, they set tangible business goals like boosting revenue by $20 million through smarter product recommendations. Finally, they define milestone and metrics, the checkpoints that show whether the ML model is moving in the right direction or not. These benchmarks aren't just numbers, they are guiding compass for the entire project. If the metrics fall short, it's a signal to step back and rethink the strategy. So, what is the role of data science team? Once the product team defines the problem, the data science team takes over. Their first task: check if the data even exists for the use case. If it doesn't, then they'll recheck. If it does, they move into model selection and design, choosing the right algorithms and building a prototype model. If the data doesn't exist, they'll collaborate with the data engineers to find ways to collect or generate it. So, in short, the data science team turns business goals into technical blueprints. What is the role of data engineering or analyst team? Next comes that the unsung heroes behind reliable data flow. They build ETL pipelines that continuously extract, clean, and load data into data lake houses. Without them, the data science team wouldn't have consistent or high quality data to work with. In production, these engineers set up a real time infrastructures that stream live data to the model so it can keep learning, adapting, and being monitored continuously. They are the ones ensuring data never stops flowing. And finally, the MLOps or the DevOps engineering team, the people who make sure that all this theory actually runs in the real world. They decide where to deploy the model, whether it's on premise or in the cloud or in the hybrid setups. They build APIs that connect your ML model with the applications or user facing systems. They also handle CI CD pipelines, automating model deployment and versioning so updates roll out smoothly. And once the model is live, they monitor performance, manage infrastructure, and handle retraining, ensuring the model doesn't decay over time. If you are already a DevOps engineer, stepping into MLOps just means adding one more layer, understanding the ML lifecycle, data drift, and model registries. So, what makes an ML engineer team powerful isn't just individual expertise, it's collaboration. Each role depends on others. Product managers guide direction, data scientists build intelligence, data engineers feed the pipelines, and MLOps engineers keep it all alive in production. Together, they transform raw data into real business impact. So, that's the anatomy of machine learning team and a perfect balance of business understanding, data craftsmanship, and operational excellence. If you are someone aiming to join or build such a team, remember this: machine learning succeeds when humans collaborate as effectively as the models they build. Right. Thanks for watching till now. I'll further proceed with the other things. If you found this useful, please like, subscribe to Data Enthusiast Era, and stay tuned. We will explore how these roles work in real MLOps pipeline. So, if you have ever wondered who keeps machine learning models alive once they leave the lab, meet the ML ops engineer. In this, we will explore who an MLOps engineer is, what they exactly do, and why this role is the bridge that connects data science brilliance with real world production systems. So, who is MLOps engineer? They sit right at the intersection of data science and operations, managing everything from model training to deployment, automation, and monitoring. At the core, an MLOps engineer is a DevOps professional who applies the principles of software engineering to the world of machine learning. What is their mission? To make machine learning workflows reproducible, scalable, and reliable, not just experimental notebooks that never see daylight. So think of an ML engineer as the conductor of entire ML pipeline. They design and maintain end-to-end workflows from data ingestion to deployment and monitoring. So models can move smoothly and automatically between stages. When done right, this automation frees up data scientists to focus on experimentation and innovation rather than worrying about the infrastructure. MLOps engineers streamline machine learning lifecycle by turning complex manual steps into standardized and automated process. They ensure models can be trained, versioned, and deployed sorry with consistency, reducing errors, improve reliability, and speeding up the entire delivery process. Just like DevOps uses CI/CD for software, MLOps engineers use it for machine learning models. They build pipelines that automatically test, validate, and deploy models whenever there's a new update, maybe new data, a better algorithm, or a retrained version. This ensures the latest, most accurate models reach production quickly with minimal human intervention. ML engineers are also the connectors between the teams. They create collaboration frameworks using tools for version control, model registries, and experiment tracking so everyone stays aligned. When data scientists, engineers, and product teams work within the same structured system, the entire ML workflow becomes faster and most transparent. Automation is where MLOps truly shines. MLOps engineers design pipelines that automatically retrain models whenever new data arrives and then redeploy them seamlessly into production. This reduces manual errors and ensures the model is always learning from the latest information. I can give a quick tip: automate wherever you can. It's not only saves time but keeps your systems far more stable. After deployment, the work isn't done, it's just beginning. MLOps engineers continuously monitor model performance in real world conditions. They watch out for model drift, where predictions start to go off track because of changing data patterns. Through automated monitoring and alerting, they ensure the model remains reliable, accurate, and scalable. By refining the entire workflow from model development to production, MLOps engineers drastically cut down time to market. In industries where speed defines competitiveness, this role helps businesses deploy smarter solutions before anyone else does. Finally, scalability. MLOps engineers design cloud native architectures that automatically scale as data and traffic grow, ensuring models perform efficiently even under heavy load. They use containerization, orchestration, and monitoring tools to keep deployments robust, cost effective, and production grade. So here is the bottom line. An MLOps engineer is more than just a coder or data handler. They are the bridge between the innovation and execution, ensuring that ML models aren't just built but truly used in the real world. If you want to work at the heart of AI production systems, this is the role to aim for. And I'm asking again, please don't forget to like, subscribe, and drop a comment below if you want me to cover any other thing. I'll continue in the next topic. If you have any questions, please comment in the comments box. I'll try to reply on that. We explore how DevOps tools strengthen machine learning operations. These tools form the bridge between model development and production, improving automation, scalability, and reliability. By connecting data pipelines, code integration, and deployment, DevOps becomes the foundation for effective MLOps practices. The focus of this is twofold. First, we review how DevOps principles adapt to machine learning systems. Then we explore essential tools organized by category, each improving collaboration, automation, and monitoring within an end-to-end MLOps pipeline. Version control and collaboration. Version control supports teamwork and experiment reproducibility. Source control systems manage code configuration changes, while data versioning ensures datasets and models remain consistent. Together, these tools provide traceability and structure around every stage of an MLOps project. Continuous integration tools. Continuous integration automates the testing and building of machine learning workflows. It reduces manual effort, improves code quality, and ensures that every change is validated before merging. This automation allows data scientists and engineers to move quickly without sacrificing stability. Continuous deployment manages the process of releasing models into production environment. If uses automation to deploy models reliably, maintaining the infrastructure consistency and support rollback with well-designed pipelines, updated models reach production safely. You might be wondering which tools to be used. I'll just go back and explain maybe that first. So you might need to find the relevant tools first. We'll start by understanding why DevOps tools are crucial in MLOps, and then we will explore each tool category from version control to monitoring, testing to orchestration with the examples of how they fit into real world ML workflows. Let's start with the foundation version control and collaboration. Git is the global standard. It tracks code changes, branches, and merges, keeping your entire team aligned. Platforms like GitHub and GitLab make collaborations effortless. But for ML projects, we need more than code tracking. We need data and model versioning too. That's where DVC data version control comes in. It extends Git to handle large datasets and machine learning models, ensuring full reproducibility of experiments. Together, Git and DVC are your safety net for collaboration, rollback, and consistent experimentation. In MLOps, CI tools automate testing, building, and integration of code and models. The most popular ones are Jenkins, the CI/CD platform that handles testing and deployment with incredible flexibility. GitLab CI/CD built right into GitLab repositories, perfect for integrated testing and deployment workflows. Circle CI, known for its speed and easy integration with Docker and Kubernetes for scalable cloud builds. These tools ensure that every change, whether code or model, is validated automatically before deployment. Now comes continuous deployment, where your trained models actually reach production. Here are the key players: Terraform Flow, an ML deployment platform, builds on Kubernetes for creating pipelines, training, and deployment. Terraform, the go to infrastructure as code tool for provisioning compute, storage, and networking resources across cloud providers. Argo CD, a Kubernetes native tool that ensures your deployed ML models always match the version in your Git repo. Perfect for GitOps style automation. These tools make deployment faster, safer, and fully automated. No manual steps, no inconsistencies. When it comes to experiment tracking, two names stand out: MLflow and Neptune.ai. MLflow, the all in one platform for managing the entire ML lifecycle from tracking experiments to deploying and serving models. Neptune.ai, a great combination for experiment tracking, visualization, and collaboration. These platforms help data scientists compare model runs, visualize performance, and reproduce results quickly. In real ML workflows, they are the black box recorder, keeping a trace of every experiment you have ever run. Automated testing isn't optional in production ML, it's critical. PyTest is your go to for testing machine learning scripts, ensuring models behave as expected across environments. Great expectations focus on data quality. It defines expectations for your datasets and warn you if something looks off, like missing variables or the values or schema mismatches. Together, they protect your ML pipelines from silent data and logic errors before they cause problems downstream. Containerization and orchestration make ML models portable and scalable. Docker packages your model with its dependencies, ensuring it runs the same everywhere from your laptop to the cloud. Kubernetes takes it to the next level, managing deployment, scaling, and health checks automatically. Together, they form the heart of scalable MLOps, gives you flexibility, reliability at every stage. Three dashboards. So once your model is live, monitoring becomes your best friend. Prometheus collects and stores performance metrics like latency, throughput, and accuracy. Grafana turns those numbers into beautiful real time dashboards. Elastic Stack, ELK, Elastic Search, Logstash, and Kibana offers a powerful alternative for detailed logging and analytics. These tools ensure your production environment stays healthy and transparent, and they help you catch issues like model drift or infrastructure bottlenecks before users even notice. Now, let's talk about security and orchestration, two areas you can't afford to overlook. HashiCorp Vault securely stores API keys, secrets, and sensitive credentials. Sonar Cloud scans your codebase for security issues and ensure compliance. For workflow orchestration, Airflow is the most standard. It schedules and monitors complex pipelines across data ingestion and model deployment. Lugi is an alternative, though Airflow is far more widely adopted in MLOps today. These tools keep your operations secure, or auditable, and well coordinated. Once your pipeline is automated, these tools take your model's performance to the next level. Optuna, a flexible, efficient framework for automated hyperparameter search. Hyperopt is another solid library using advanced algorithms for tuning model parameters. They help you squeeze out best policy accuracy with minimal manual effort, automating one of the most time consuming steps in ML development. So, there you have it, the complete toolkit that bridges DevOps and MLOps, from Git and DVC for collaboration to Jenkins Terraform Argo CD for automation to MLflow, Airflow, Prometheus, and Optuna for monitoring and optimization. Each plays a unique role in keeping your ML systems automated, scalable, and production ready. So, if you are serious about becoming an ML ops engineer, mastering these tools is the next big step. But don't worry if you are hearing lot many tools. Once you know in and out about the tool, so it will be easy. Thanks for watching till here. Hit that like and subscribe button to Data Enthusiast Era and drop a comment if you want me to make a video on any other thing. We will continue with the next topic. We will explore the high level architecture of MLOps, the framework that connects every part of machine learning project from data collection to model deployment and monitoring. Let's see how all pieces fit together into one seamless workflow. The MLOps process begins with defining the problem statement clearly. Once that's done, data is collected from various sources, databases, spreadsheets, or public repositories. After ingestion, data is transformed and cleaned to handle missing values, duplicates, or inconsistent formats. This refined dataset is then analyzed, where visualization and correlation help uncover key insights tied to the business code. Remember, good quality is what everything else possible. So, here comes the decision making stage, determining whether a machine learning solution is actually needed. If not, the team revisits the problem statement, but if ML is a good fit, the process moves to feature engineering, identifying which data features matter most and storing them in a feature store for future use. This stage sets the foundation for building smarter, more efficient models. Once the right features are ready, it's time for model exploration and training. Data scientists experiment with multiple algorithms, comparing results and documenting their findings. After selecting the most promising model, it's trained on a larger dataset. Then comes model evaluation, comparing performance metrics with the original problem statement. If it falls short, the cycle repeats until the results met expectations. Model refinement is what turns theory into real world performance. Once the model performs well, it's deployed into production where it starts interacting with live data and users. But deployment is only the beginning. Continuous monitoring ensures the model performs reliably as data patterns shift. When performance declines, the system triggers retraining using new data, restarting the cycle from collection. That's how MLOps keeps models fresh, accurate, and relevant over time. Behind every successful pipeline is an ML ops engineer. They build and maintain the systems that automate data ingestion, feature engineering, model training, and deployment. They also manage CI/CD pipelines, monitoring data dashboards, and debugging tools that keep everything scalable and production ready. In smaller teams, MLOps engineers may also handle data collection and transformation, bridging the gap between data science and operations. This is the full picture of MLOps architecture, a continuous feedback system connecting data, models, and production. Each component is dependent on other, and automation is what makes the system scalable. From defining the problem to continuous monitoring, MLOps ensures every ML's project stays adaptive, measurable, and production grade. And that's how MLOps architecture works end to end, transforming data science experiments into scalable automated systems that deliver real business value. Those who build a career in MLOps should focus on mastering this workflow. It's where DevOps, data engineering, and machine learning come together. That's it for this video. Thanks for watching. Hit that like button and comment below if you have any questions. And please subscribe to this channel for more videos. Thanks for watching.